Starting with exercise 3D, understanding decimals. Now, first part of your work. Listening, eyes and ears towards me. You need to know how to use what they call inequality sign. So you have a less than or a greater than symbol. Now we always read from left to right. So when you use them, we always ask, is this number, so on the left, greater than or less than the number on the right? Okay, so let's have a look at the numbers here. We've got 42.1637 and we have 42.1619. In order to tell if a number is larger than another, you need to know your place values. Okay, so our place values are units, tens, hundreds, thousands, 10,000s. Okay, those are called place values. When you go into the decimal region, we now call them with a TH at the end of it. Tenths is what we start off with. Hundreds, thousands, and then 10,000s. Now, what's important that I want you to take as part of your notes for today, I know most of us know which one is larger and which one's smaller, so that's pretty straightforward. What I think that students don't fully understand is the place values help you do conversions from fractions to decimals and decimals to fractions. And I'm going to show you, it's a very simple idea on understanding one concept in primary school, and it's what place values mean. Now, let's write a random number. I'm going to do 72518.137. Actually, I'll do 7 again, yeah. 6, and what number haven't I used? 4, okay? We know these are units. How many units make up 1/10? 10. Now this is going to be important, which explains why the next technique I'm going to show you why it works. You said that 10 of these units, so 10 groups of these units equals to 1/10. How many of these tens do I need to make one of these hundreds? 10 again. This is why it's special. So 10 groups of tens will give you one of these hundreds. Okay? Now, if I go into the decimal region, this is where students seem to have a vague understanding here. This is your tenths column, the THS, right? Now, my question is, how many tenths do you need to make 1 unit? So 10 again. So I'll write it again here. You need 10 tenths, 10 of these tenths to make 1 unit. Now all of them is based on what we call the metric system. Not like in London or in London they use the imperial system, miles and pounds. We use the metric system, which means it's in groups of 10. So we like that. We like it in groups of 10. Now, this is special because when you get something like, say, 21, and I say, multiply that by 10. What's 21 times 10? 210. But what students don't realize is part of this 1 right now, which position is 21? What's this 1 called? What place value is that? The units. You see, for every one of these place values, the 2 tens, this is 2 tens, you're going to get 10 groups of that, because that's what times 10s mean. You're going to get 10 groups of the 2s, you're going to get 10 groups of the 1s. Now what's special is we said, right here, we said that if we had 10 of these units, it makes up 110. If you have 10 of these tens, it makes up 100s. This is why the number 2, which is currently in the tens column, it moves to the hundreds column, which is over here. Because we're saying there's 10 of these groups of tens. That's why the 2 ends up in the hundreds. And then same thing with the 1s. If it's in the unit section, you get 10 groups of them. Instead of moving from the units, it now moves to the tens. Now, this may feel quite straightforward, but this explains why, when you're doing something like this, which we're going to do in decimals, you learnt this maybe in primary school. Some of us know it, some of us don't. If I gave you 21.73 and I said times this by 10, anyone know what the answer is?
217.3.
Good. Those who didn't, yes. So, Luca just said that you can move the decimal point 1 point across because there's that 0 there, which means it's one movement, right? One movement to the right. And that now gives you 217.3. Now, a lot of students will learn how to do this, but they may not understand why this works. And it follows exactly what I just said. Every one of these place values have moved a shift up from the ones in the units column now is going to be in the tens column. The 2 in the tens column now becomes the hundreds column. The 7 in the tens column becomes now the units column. You're literally just moving it on the place value system. That's all it was. It was just groups of 10. That's why it feels like you're moving the decimal away, but you're not. You're in fact moving the numbers away. You're moving the place values away. That's what the groups of 10 do. Okay? But if that theory didn't make sense to you, yeah, you can memorize this. You can memorize that if you times by 10, you get larger, so you move decimal point to the right. What about division? What if I gave you 356.152 and I said divide 100? What does that equal to?
3.56152.
Very good. So in this case, when you're dividing, you're getting smaller. So we move to the left. We move the decimal point. Instead of moving to the right, we move it 2 place values. Because 100 is 2 groups of 10. So that means you're moving 2 place values away or smaller. So here, you can think of it as the decimal place moves to the left by 2. And you would then say your answer is 3.56152. Now you can memorize that technique or you can understand what you're actually doing. When you're dividing 10, you're just moving it 2 place values back. So right now that was meant to be 300s. 2 place values back becomes now 3, ends up being a units. Hundreds, tens, units. 2 decimal places back or 2 place values back. That's what that is. Okay? So, let's have a look. Your first question that you need to do as part of exercise 3D. Very simple. Your job is to figure out which one's larger or which one's smaller. Let's have a look. Question 1A. Which one's larger, 42.1637 or 42.1619?
The first one.
Why is that? How do you know?
Because it's got the higher number first.
Which number are you looking at? Which number? 3. So we can see 3, and over here is a 1.
Yeah.
So 3 is greater than 1. So the symbol you should be using should be this. This means the tail end is saying this is smaller and this is larger. Okay, so you've got question 1 and 2. Listening? Thank you. Question 1 and 2, you're learning to use your symbols. And please don't forget my rule. I had 3 rules, Ivy. I had 3 rules out of respect. You're actively listening and you're actively taking notes. But you're not actively speaking while I'm speaking. Because that's disrespectful. You can choose to speak after I finish. Right? You can choose to speak after I finish. But you don't have to do it while I'm doing it. That's disrespectful. You've got a lot of other times to do that. So actively listening or actively writing. That's what I'm expecting. Okay? Not concentrating on your laptop and playing games. Okay? Here we go. So the first 2 questions you would be able to go through fairly quickly. Which one's greater? Which one's less or less than or greater than? The tail end is a giveaway. Wherever the tail end is pointing towards to, that must be the smaller value. So we know that 42.1619 is smaller than 42.1637. This is fluency section, correct. Okay, so we've got question 1, 2 was straightforward. Let's move on to the next part of the question.
Why is it so blurry?
Because I think I accidentally made it smaller. Now, Question 4, 5, and 6. Question 3 is arranging from descending order. What does descending mean again?
Like lowest to highest.
The other way around. Descending, so you're decreasing, so it drops from highest to lowest. So here, make sure to write a note, lowest to highest. Oh, sorry, what am I writing? Highest to lowest. Highest to lowest. Now, what I'm interested in teaching you today, and that's why I started off with teaching you the place values, I want you to understand how to do question 4, 5, and 6. Those are your skills that will set you differently. So when I give a test, I often know 4, 5, and 6 is what students struggle with. And the reason why you struggle is to do with your times tables, also your division. If your times tables aren't good, your divisions aren't good. So let's do a couple examples together to get you knowing how to convert from decimals. How do you convert decimals to fractions? And then how do you convert fractions to decimals in its simplest form? Okay, so this will require a times table. The more you practice, the better you get. Let's do some examples here. I'm just going to go down here. I've got question 4 ready. Remember, this video, I've already made some examples up here. You can watch the video for me to show you how I do the conversions. Okay? But here we go. Let's do question 4 together. We are going to convert decimals to fractions. We're going to do it in their simplest form. Here we go. Let's pick a question. Let's do D to start off with, something that's nice and easy. And then we'll do G. And then we'll do I. Okay, here we go. Let's do this together. D. 0.96. When you're doing this, I want you to use what you understand about the place values. Okay? Changing decimals to fractions is literally your skill to read the decimal places. That's it. There's nothing more. The better you understand the place values, the easier it is to do these questions. Here's how I would do it. The 9. What place value is this? Where's the 9? What do we call this place value? Tenths. What about the 6? Hundredths. So hundredths is the last digit you see. So I'm going to highlight that. This is your hundredths. Anyone know how to write hundredths as a number? What's 1/100th? What does that look like? Because we know what a unit is. A unit looks like this. Tens look like this. Hundreds look like this.
0.01.
0.01. What about as a fraction?
1/100.
Very good. So this is the key part that I want students to understand. When you say hundredths, this means 1 out of 100. Tenths means you've got 1 out of 10. Whereas units is technically 1 out of 1. Notice the pattern. Can you see how the 1 increases in the denominator with one metric system of extra tens? That's all it does. That's why thousandths has an extra 0 and it keeps going. So 1/1, that's why we know that's units is 1. And then over here it's 10/1, 100/1. It just follows a pattern. Okay? Now, if I were to write this as a fraction then, this is all simply, since I've got 6 as my hundredths, that means I've got 96 hundredths. So if I were to write that language down, this is what your answer should look like. 96 hundredths. That's it. I'm literally just reading what I see. See, if I were to read this one, I look at the 7. What place value is the 7 over here in the B? What's the place value for 7? Thousandths. So if I were to read this, this is 537 thousandths. So if I were to write this as a fraction, it is 537 thousandths. See, converting decimals to fractions isn't that hard because all you're doing is you're reading it. So if I read this one, this is 31 hundredths. Because that's what it is. The 1 is the hundredths column. I've got 31 of these hundredths. But your job, and this is where it's not the reading part that was difficult. You know what's the hardest? The hardest is to simplify it. Because we don't want to be writing something like, which one? Let's do that one. That's a big fraction. It's a huge one. We don't like working with large fractions. We like working with smaller ones because it saves us time. Your job now is to somehow simplify, say 96 over 100. You have to simplify this. And this goes back to what you've been practicing in exercise 3A, equivalent fractions, finding a common factor. But the only way you can do common factors is your times tables need to be strong. So here we go. We've written as fractions, but they wanted us to do it in simplest form. Your job now is to find a common factor. So I've changed it to a fraction. Great. But I need it in simplest form. What is a common factor of 96 and 100? I normally try to break it down smaller. So notice they're both even numbers. Now if they're even numbers, what's a common factor? 2. So I would just say divided by 2 until you get as small as you can. So let's try dividing them by 2. What's half of 96? 48. Half of 100? 50. And we can both see again, it's still even. So let's do it again. Divided by 2. Divided by 2. You can do this as many times until you get the fraction as small as possible. Half of 48? 24. Half of 50? 25. And what you can see here is they're both no longer even. Now you go through your times table to just double check. Is there a number that can go into 24 and 25 or has a common factor? No, there isn't. That's your simplest form. So what I've done, what I've done is I've converted 0.96 to a fraction by reading the place values, and then I simplified using exercise 3A, which is highly reliant on your times tables. So the better your times tables, the better you can do this part. And that's where each and every one of you will differ, but it's not the theory. So the theory was straightforward. I was teaching you how to read. We're just reading the place values, and once you can read it, you can convert. But not all of you will be fast with factorizing, or not factorizing, simplifying. Okay? And that's where if you keep training with those times tables, you will get better. The theory is straightforward, and as you build on your times tables, you'll find it's much easier to do. Okay?
What are the ones in blue, sorry? Are they
The ones I'm going to do.
you're going to do?
Yeah, because I just did D. Okay, now we're going to do G. Let's do G now. So we're going to do the same thing. Let's do G together. So question is 26.8. Let's break this down. So writing it as a fraction, I've got 26. Pretty straightforward. I know how to write 26. That's 26. Right? But what's the 0.8? What's the 8? What place value is this? Tenths. So I would say I have 8 tenths. So here we go. 8 tenths. So I have 26 and 8 tenths. It's a mixed fraction now, right? But the 26 was 26 wholes. So I'm just trying to convert by reading the place values, and I've converted them into a fraction. So 8 tenths is what I wrote. Now 8 tenths, it's not in its simplest form. We have to look at this fraction here, 8 and 10. Is there a common factor? 2. Very good. So we can see they're both even numbers. So I'm going to say, all right, how many 2's go to 8 and how many 2 goes into 10?
4.
4 and
5.
5. So we got 4 fifths. Now you can change that to improper if you preferred improper fractions, or you can leave it as 26 and 4 fifths. But can you see the conversion wasn't hard? The skill that you're training on is simplifying. To do that, it is times tables. Okay, now let's try the last one as part of my example here. I 0.052. Read the place values. Here we go. Looking at the last place value, I've got a 2. What place value is the 2? Not hundreds. Be careful. This is your tenths. Hundreds is here. Thousandths. Now thousandths, I've got 52 thousandths. So let's write the fraction down. 52 thousandths looks like this. So you've successfully converted decimals to fractions, but your job, which is the toughest part, to simplify. Okay, so you want to find the simplest form. How do you do that? Let's have a look. 52 over 1,000. Listening. Thank you. Thank you. Active listening or active note taking? Okay. Eloise, you were saying?
26.
Very good. And again, both are even numbers, so we're going to divide them both by 2. When you see even numbers, break them down until you can get to the smallest value. We've got 26 over 500. Both are still even numbers again. So we're going to try it again. Divide it by 2. What's half of 26? 13. What's half of 500? 250. And then before you always finish, double check, are there common factors between 13 and 250? If there aren't, that is your simplest form. Okay, so that there, remember I've made a video up here for you already. If you happen to need some revision,